Hey, hello everyone. Welcome to our channel Physics, where we actually learn physics. So now we are gonna solve this very simple question, that is 2.18 from our chapter 2. Okay, units and measurement. Okay, units and measurement from 11th standard. Okay, from the CBSE board. Okay, so this is what we are going to solve. So it's a very simple question actually, okay, that you can see on the screen. It's just a question about discussion about some phenomenon. Okay, nothing else. We don't have to look into any numbers over here. We don't have to solve anything. No significant figures, nothing at all. Okay, so let's do this. Let's see what it is. It's a simplest one. Explain this common observation clearly. Okay, explain this common observation clearly. If you look out of a window of a fast moving train, the nearby trees, houses, etc. seem to move rapidly in a direction opposite to the train's motion. But the distant objects like the hilltops, the moon, the stars, etc. seem to be stationary. Okay, so this is a common observation that we have to explain. Okay, see again, if you look out of a window of a fast moving train, the nearby trees, okay, the nearby trees, houses, etc. seem to move rapidly in a direction opposite to the train's motion, but the distant objects like the hilltops, the moon, okay, the stars, etc. seem to be stationary. In fact, since you are aware that you are moving, these distant objects seem to move with you. Okay, so this is right now the situation which we have to explain, okay, scientifically. So the answer to this question is very simple. There is only one reason for this, okay, at least the main reason over here is the parallax. Okay, parallax is the main reason behind this phenomenon that we observe. Okay, parallax phenomenon. If you have checked my video on parallax, you will understand what is parallax exactly. Over there I have explained parallax, okay, with lot of examples also, with some experiments also. So you go and check please if you have not checked, so that you will understand this question very easily. This question is, nothing actually. This question is nothing for you if you understand parallax. Still, I will tell you what parallax is. Parallax is nothing but the phenomenon of apparent change. Okay, phenomenon of apparent change in position of nearby objects with respect to the distant objects when the nearby object is observed from 2 points of observations or 2 locations. Okay, so parallax is a phenomenon of apparent change in position of a nearby object with respect to a distant object or a distant background when it is viewed or observed from 2 points of observations. Okay, so that is parallax. What do I mean by this is, suppose let's say these are the 2 points of observations A and B. Let's say you are observing from here and here. For example, here is a nearby object and here is something distant background. Okay, let's say. Okay, so when you observe from this side, you will see the position of this object, okay, in this direction. Let's assume that there is something over here, some distant object. Okay, so if you observe it from here, you will find the position of this object in this direction. If you observe from this side, you will find it like this. Okay, for this, to understand this, take your finger like this. Okay, if you have checked my video, you will understand this easily. If you have not checked, then please watch this. Otherwise, you can skip this part and move to the answer. Okay, over here, keep your finger in front of your eyes. Okay, in the middle actually, just like this. Keep it at your nose and then just move it little bit ahead like this. Okay, something like this. Now what you do is choose some object in the background. Let's say for example right now in the background of this finger, okay, we will call this finger as the nearby object. Now in the background of this finger right now, there is a wall in front of me right now, and on the wall there is a frame. Actually there is a frame. So what I'm going to do is I'm going to consider this as a nearby object and that as a distant object. Now I will observe this nearby object with my one eye closed, okay, through my left eye, then through a right eye, again through left right, left right, left right. This is what we are gonna do, okay. And when we do so, when we observe this nearby object with respect to the background object through our both eyes, you can see the point of observations are at a different locations, 1 2. So there is a distance between the 2 points of observations. So when we observe this finger, okay, with our both eyes separately, then we find that the position of this nearby object changes with respect to the background object, but the background object does not change its position. It appears to be stationary. This phenomenon is called as parallax. Just do it. If you want to understand this, just do it right now, okay. Pause this video and do it, okay, then you will understand it clearly. If you have seen my video already, then no need to check, you will understand it anyway, okay. Anyways, so I hope you are doing this. I hope you understood what is parallax. So same thing happens when we are moving in a train, when we are looking into the window, looking out of the window through a moving train, okay. Suppose for example, let's say, see, this is the train. Let's say for example, let's say there is a tree over here, nearby tree, okay, and here are some hills, okay, here are some hills. Definitely this hill will appear to be smaller to us because it is very far, okay. Let's assume there is a hill over here, okay. So this nearby object, okay, this tree over here can be considered as a nearby object. When this train, okay, see, suppose this train was here initially, okay, because it is moving. Let's say the train is here. Now you observe this object or this tree from here, and now when you move ahead, when the train moves ahead, now you are observing it from this side. So what you will find out, okay, again you can see this is a parallax because this is one point of observation, this is another point of observation, this is nearby object, and this is distant object. So we see in the parallax that the nearby object appears to change its position with respect to the background, okay. Background appears to be at the same location or in the same direction, okay. So same thing will happen here. This nearby tree will appear to move, okay. As we move in this direction, it will appear to move in this direction with respect to the distant objects, okay, with respect to the distant objects. This is what will happen over here, okay. And that is the reason why the nearby objects seem to appear moving opposite to our direction, okay, but the distant ones don't appear to move. They appear to be stationary because of the parallax phenomenon, okay. So this is what happens. Same thing happens when you are in a car, okay. Suppose this is a car, okay, suppose something like this, okay. Please mind my drawing over here, okay. So let's say this is a car, something like this, okay, and it is moving in this direction, okay. So let's say there is some building over here, or some, again let's say tree, okay. Let's say here tree, okay. Here is a road actually, okay. Here is the road, and now on the other side in the background there is a sun, let's say, okay. There is a sun, let's say, okay. So when you will observe this tree from here, when you are at this position, you will find out, okay, it to be here in this direction with respect to the sun, but you will find out that the sun is in a particular direction. It is straight like this, okay. It is in a particular direction only, okay. Sun is in background. We generally see that the sun does not change its position, okay, with respect to us, Okay, so when we will reach here in this car, okay, when we will reach here in the same car, again please don't mind my drawing over here. Okay, so when we will observe from here now, okay, again we will find that the tree is in this side. Okay, so we will find that the tree has changed its position, but the sun is still in the same direction that we were observing it. Okay, sun is still in the same direction because it is very far. Okay, so this is nothing but the parallax phenomenon. Okay, this is what happens, and that is the reason why this tree appears to be moving backward. In fact, if there was any other object, that would also appear to be moving in the opposite direction if you are moving in this direction. Okay, so this is what actually happens. Okay, this is what actually happens. Okay, this is a common observation actually. This is all because of the parallax method or parallax phenomenon. In fact, since you are aware that you are moving, these distant objects seem to move with you. Okay, so that is also easy to explain. See, when you are in the car, okay, and if the sun is here, let's say in this direction, even if you move in this direction, still you find that the sun is in the same direction. Okay, you just check, go and check. Okay, suppose you are here in a car, let's say at this position. Okay, you are here, let's say. So the sun is, let's say, over here in this direction. Okay, let's say there is a sunset, for example, and even if you move here, still you will find out that the sun is here. Okay, sun is still in the same direction because it is very far. It is very far. The objects which are very far do not appear to change its position. They appear in the same direction. This is nothing but the parallax. Okay, so here the same thing is happening. It's a parallax only. Okay, it's a parallax only. So since here you can see the position of the sun, okay, position of the sun or the position of the distant object with respect to you does not change. That means what? The sun is not moving with respect to you. Okay, sun is not moving with respect to you. Sun is stationary with respect to you. Okay, sun is stationary with respect to you, isn't it? Okay, this is what you will observe. This is what you will feel, that sun is stationary with respect to you. Okay, but you know that you are moving. So that means you can say the sun is also moving with you. Okay, because the position is not changing. Okay, so if you don't want the position to be not changing, that means the sun also has to move with you. So this is what you will feel, like sun is also moving with you. And actually also you observe the same thing. When you observe the sunset, you observe the same thing. You observe that the sun also moves with you, but actually it is not moving. That is just a parallax method, just a parallax phenomenon. Okay, this is what actually happens. Okay, so this is the common observations. Okay, so I hope this is clear. This is all about parallax actually, nothing else. Parallax, and one more concept, that is relative velocity. Okay, relative velocity. So I hope this is clear. This is simplest question. Okay, so we will stop over here and we will see the next question in the next video. So for now, thank you so much for watching. Thank you so much for listening. Have a nice day. Bye bye. See you.